But it is a special stop. I didn't want you to miss this because it is sort of a very, it's something you don't see usually in a tour. And we're just going to be looking into this particular lava tube. And I'm going to talk to you about it very briefly. And then you're going to do a rest stop. So you can use the facilities here because you have to stay on a schedule. So don't go scampering off. As soon as I'm done talking, take some photos. Use the rest facilities and come right back. And the most important thing is, believe it or not, be very careful right here crossing this road. They're coming down off the saddle, and I tell you, people just like to speed up because they're coming down from Mauna Kea. So be very careful crossing the road, and let's just go over. After this car. Yeah, there's a truck coming down.
He's stopping.
At least one stop.
Not from LA.
Có những đâu này là phá lắm thấy không? Những video ra.
Let me just first describe to you what's happening here, and then you can do, take a few minutes to explore. Now, you're not going to have much, you're not going up to the Volcanoes National Park, and so you're not going to be able to see much. I'm going to be giving a talk about volcanoes, but here you can at least get to see something spectacular. And that is, this is called a lava tube. Just imagine it as a subway system for lava that's coming down. In this case, it's coming from Mauna Loa volcano. All right, so Mauna Loa is another 14,000 foot high volcano. That's from sea level. And then it goes down 32,000 feet it's measured from the ocean floor. So it's the largest landmass for a volcano construct on Earth. And so this is a lava tube in which lava flowed down through it. Up there, lava flows downhill to the sea. And this particular cave, this is called a skylight, so it's sort of like a manhole cover, right? Gases from inside ate away the rocks, it fractured it, and it collapsed inward. But I'm going to tell you something a little bit more how lava tubes form. But the most important thing is that this is the cave, I think it was from 1883, but it was the first recorded lava tube for a documented lava tube. Someone actually walked up and they were able to stand on the edge and look as lava flowed beneath his feet, through that. And he was able to describe what he saw. And so that was the first documented case of a lava tube, and that's why this in particular is in history. Inside the cave, you'll find there are etchings going back to I found at least to like 1911.
So was that when he saw this?
No, it was in the 1800s, late 1800s.
It was in the 1800s.
What is the distance from the origin of the lava flow?
The origin is from upward.
What's the distance?
The distance is probably from here to here, probably about 25 kilometers.
Oh.
Yeah. So 25-kilometer long river. Yeah, now to tell you, I was here for a 1984 eruption of Mauna Loa, and we did that. We went up a 20-kilometer lava flow, and we were in a helicopter, and we did it with our headphones while listening to the Blue Danube waltz. We were just going up the flow. That was gorgeous. That was something else. But now, what do you think? How do you think the lava is formed? You think it just bores through the Earth?
I think it cools on the top.
Formed by pressure.
Makes its own top.
Yeah, it cools on the top. Very good. So what happens is, actually, believe it or not, the lava tube starts at the surface. So it's actually starting right at the surface layer. It just starts as a normal lava flow. Normal lava flows from Mauna Loa might be pretty thick. Maybe they're about a few feet thick. And it gets channelized. But lava coming out is probably around 1500 degrees Fahrenheit. If you were to take a bucket of water and throw it into an environment that's 1500 degrees below zero, what would happen?
Steam.
Freeze. Right? It was like ice cubes everywhere, right?
Actually, it couldn't be that cold.
They couldn't be that cold. But so what happens is lava, as you had mentioned correctly, it starts off on the surface, and the surface starts to cool. And lava rock is a basalt, and it's almost a perfect insulator. And so the surface basically cools, and then the lava stays flowing underneath. So then it eats its way deeper and deeper and deeper. And so the gas fills the empty space, and the gas is as hot as the lava. So it starts to eat away at the ceiling while the lava is eating away at the floor. And over time, it just keeps on growing and growing and growing, and it gets that roundish shape. And this is kind of a typical size, a little bit larger for a typical size of a lava tube transport system to the sea.
So you're saying that basically the tube burrows rather than being built up around the. I appreciate that it starts at the surface, but it then burrows down in.
It burrows down in
to the sides being built up around it.
That's right, exactly.
Cool, I didn't realize that.
Yes, that's right.
And this part collapsed?
And then this collapses, and in my talk, I'll talk a little bit more about that. But I just want you to you can take some pictures. I just want you at least to get a sense of the size and the magnitude of the forces of the Earth by seeing something of that nature.
And can we scamper down in?
Yeah, well, if you scamper and
we scamper.
come back up, don't go all the way down.
No.
Yeah, so we're gonna leave in about 10 minutes.
All right, good, thank you, Kelly.
10 minutes tops.
10 minutes tops.
So take your pick, walk, use the restroom if you need to. It's nice and cool down here. I love it.
Rồi. Okay. Hey, you go ahead first.
You want to pass?
Yeah, yeah.
Thank you.
Được啦。係啊，幾㗎。除個鏡啦，唔好行因為。啲人就係咯，拉個柱。
佢一路咁食落去。
哇，好似個 cave 咁嘅喎，係啊。OK， 得啦。係。
我很想喺下邊影，不過冇機，得手機。
Actually, go to this side so the sun will actually get on your face. There you go. All right.
It's not going by.
Yes. No, I know. Well, that you know, besides the truth, this is kind of good. It really is. And not only that, but welcome to the saddle road, Mauna Kea, and Mauna Loa. That's why it's a saddle road, because Mauna Loa is that long mountain to behind you. This is Mauna Kea, and this is the saddle between them. That's the saddle road. Before I go on, I just want to reiterate everything about the summit of Mauna Kea first, and about what you should be doing. First of all, if you haven't done it already, the first thing you should do is get sunscreen on. Okay, we're going to be at 14,000 feet, and even here at 7, and then further up at 9,000 feet, the UV, you don't have much UV protection. So you need the sunscreen. If you don't have it, I have some, and I'm sure we can share. Second of all, you should be hydrating constantly. You know, if you haven't been on the way up, you should be doing it now. Anytime you exert yourself, hydrate. Number 3, if you have an aspirin, take it. if you didn't take an aspirin, if anyone has any aspirin, you can share. I'd recommend it. Maybe they have some at the visitor center when we go up. You may be able to buy it. And 4, I just want to make sure you know how to power breathe or pressure breathe. And what you don't want to do is hyperventilate and pass out. Because what you're trying to do is increase your oxygen supply to your blood. And it works immediately when you do it. So trust me, I'm just not saying this to make you afraid. This is something to do to maximize you having a good time at the summit, in here and at 9,000 feet. So power breathing is essentially, I would start off by doing a big sigh. Just breathe in. And then start doing it out of your mouth. And then just do the mouth. Okay? But don't do it, you know, you just remember to do it continually, not constantly. It works immediately. We've done it with the oxygen meter readings at the summit. We had fun. You know, you put it on your finger and you're down at 50%, 60% oxygen levels in your blood. And then suddenly you power breathe for like after 3 power breaths, your oxygen levels can be up to 95, 99%. So it's really something you should just remember to do. It's very important. And hydrate. Can't stress that enough. All right, so again, here we are at the saddle, and there are a lot of geological features. Now, the one thing I wanted to point out before anything ever happens is, you see all that really bright material up in the top of Mauna Kea? You have all these cinder cones, and then there's sort of a sandy colored material that looks like it's a sand flow on the very top. Anyone have any idea what that is? Ash? No. It's actually glacial till, left over from a glacier. Over the last 300,000 years, Mauna Kea has had 9 episodes of glaciation. And the last period of glaciation was 9,000 years ago. And the volcano last erupted 4,500 years ago, on average. That's just a given. It's very difficult to, quote, carbon date, especially up there, right, where there are no trees. And anyway, but here you have evidence of glaciation, and we're going to see evidence of glaciation on the way up. About when you get to about the 11,000 foot level, you're going to start to see large piles of volcanic rubble just piled up, and that's actually the glacial moraine. It's where as far down the glacier got, deposited all this material. Some are side moraines, and then it receded. You still get snow. There's a perpetual layer of permafrost at the top, just sort of like Mars, right, Kelly? Like Mars has a perpetual layer of permafrost. Is that true? This is a shield volcano. As you can see, the long slope of the volcano. You notice how long it took to get to 7,000 feet. A long, gradual ride, and that is because of the long slope of a shield volcano, which erupts along mostly from the summit region, but also from rift zones that go along the long sides. So lava can come out and flow along the sides or come out at the top, which create these shields because they look like overturned Roman warrior shields or an upside down plate. Now, the last period of volcanic activity was 4,500 years ago. Still hearing debates as to, it seems to be saying that it was at the summit. But usually when volcanoes are this tall, imagine from the seafloor now, we're looking at about 32,000 feet, that lava has to come up from the deep within the mantle, then it has to come up and keep rising, keep rising, keep rising. Eventually, when you get these really tall volcanoes, lava kind of says, you know what? It's a lot easier to go out to the sides, right? So some of the cones you see right here have also been indicated that some of these might have been the last period of eruptive episode. Let me just, now we built these observatories. There's a solar observatory at the 11,000 foot level on Mauna Loa. and we have the largest telescopes in the world on Mauna Kea. There's like 13 telescopes now, arrays of sub-millimeter dishes to the keks, the twin keks, 10 meters. Now, what do you think about volcanic eruptions? 4,500 years ago. Safe? Pretty much, right? Without years ago, it's a pretty good bet, right? Now, a volcano is considered active, or active is erupting. It's still considered a live volcano with the possibility of erupting if it's 10,000 years old. Okay, can you say, oh, what's the probability of that happening? Well, it just happened about 2 years ago in Chile. Volcano in Chile had not erupted for 9,000 years, and it just erupted. And you've probably seen the photos. It's the one with the huge eruption plume with all the lightning shooting out of it. You might have seen it. Okay, so this thing can erupt at any given time. There is lava underneath it. It does have earthquakes. And not only that, but what about Mauna Loa? So Mauna Loa, right? So you saw Mauna Loa in the 1800s. That had already erupted. Last time Mauna Loa erupted, 1984. In fact, Mauna Loa used to be Hawaii's most active volcano until Kilauea just started doing its thing 25 years ago. So it's Mauna Loa is really the big, they say here, the big kahuna on here. So what does Mauna Loa mean? Long mountain. Remember I said, look at that really long mountain? So Mauna Loa, Mauna is mountain in Hawaiian, Loa, long. Mauna Kea, Mauna, mountain. Kea means snow, or white, the white mountain. So you have the you have the snow god, like all the what you're standing on here, you're standing on called pahoehoe lava. Okay, it's a very fluid, very hot flow, probably 1,500 degrees Fahrenheit, flowing along the ground. And see, it didn't wait for the traffic light. They actually built the road over it, and it continued to flow across there. So that is the extent of this flow. Where did it come from? Right, there we go. Mauna Loa. So this flow, all the way over there, Mauna Loa. Okay, last time Mauna Loa was, yeah, Mauna Loa, and it was like, where's it going? Okay, evacuate Kona, because it was going down to Kona. No, wait, stop, evacuate volcano, because it's headed down to a volcano, right? I was like, no, stop, evacuate Hilo. It's coming down to Hilo. And then it continued to come down to Hilo. And then it did, and then it was beautiful. It had a 2-mile long curtain of fire right in the summit. It's like seeing Olympus Mons, the summit caldera of Olympus Mons. It just curtain of fire coming out of it. And then it went down into light, and it went outside, 9,000 feet, popped out on the heel side, and then it built a curtain of fire, just ripped open, long sea, lava shooting out everywhere, and then it just concentrated into this few cones, just this one region, and that's when we had the Blue Danube Balls time.
Is it possible for them to erupt simultaneously, or they're part of the same range?
Excellent question, and the answer is yes. Yeah, it is possible, because when Mauna Loa erupted in 1984, Kilauea was erupting every single month, fortnightly, almost tied with the 90th percentile to the tidal influence of the moon. And so they knew, they were watching it, and it was going and going and going every month. And Mauna Loa erupted, and then it was like, well, what's going to happen to Kilauea? I was like, Kilauea erupted. So there's the same mantle plume source. Tomorrow I give a lecture on volcanoes. Yeah. So, and anyway, but there's this plume. it's both. It's feeding both, but there's two independent sources. It appears at this time, as far as they know, that the two have independent sources coming from the same deep reservoir.
So if one is erupting, then
it will not deplete the other.
Watch, hold guard, I guess, on the others then too, because it could wreak havoc quite a bit then.
You know, it could, but not only that. You know, we forget some other things. You know, for example, beyond Hawaii is made up of 5 coalescing shield volcanoes. Right? You have Mauna Kea, Mauna Loa, Kilauea, Kohala, and Hualalai over on the Kona side. Only Kohala has moved off what's called the hotspot, and I'll be talking about that tomorrow in the lecture. So all of the other 4 volcanoes have the potential to erupt. And Hualalai last erupted in the 1790s, I think it was 1791, and it erupts on average every 200 years. So you do the math.
When was the last eruption on Kilauea?
It's right now.
I'm sorry, no, Haleakala.
Oh, okay. Now Haleakala last erupted also in the, I think that was also in the 1790s or so. Now,
So it's still technically active?
There's a part, the south, of Maui on the probably the southwest rim zone that is still active, yes, and has the potential to erupt.
And what about the volcano undersea?
Luihi.
Yeah.
Yeah. Yes.
Okay.
I'll be talking about that. Do you have a question on it?
Yeah. When do they think its growth rate will be at
Yeah, I would find real estate on it. Yeah. It's gonna be a while. It'll be a while.
hundreds of thousands?
Yeah, I mean, I'll look it up for you. I forget the number, but it may be something of the order of 30,000 years.
Okay, so it's not a real estate bargain.
It's not a real estate bargain. No. I knew that was. You know, I was. I was gonna say don't buy it yet. No, you might do it in some of the places we're going. I'll be talking about that later. But you know,
I'll tell Bernie Madoff.
Yeah. But Louis,
when he gets
no.
out.
Nonetheless, you know. But you know what? I have no idea. Who knows? All we can do is say this is what's happening right now. If this thing just goes into a burst of activity and starts going, and it doesn't stop, who knows? Okay, Pohoi lava.
What makes the difference between the two kinds?
Yeah, and the other one is and you see that kind of chunky stuff over there, like tall. And there's better examples.
Well, we stopped to take the picture quickly. It was all
So, and that's
Oh,
because you step on it with your feet. The difference is temperature, and so what happens is, and also gas content. So what happens is Pohoi lava is usually coming out of either the fissure, open fissure is flowing out, or from a lava tube, it breaks out of a lava tube. So it's fully gassed. Very hot, very fluid, and so it just moves with the gas expansion. The gas expansion within inside just keeps it going, and of course the pressure. Regulation, right? In the sense of pushing the gas is constantly expanding, so it constantly breaks out into little lobes and tubes. And so it's generally a very low, flat, soft flow, except when it buckles. You see, like down here where it's ropey, it's called ropey down by that bush down below. And that's because if you ever take something like brownie batter, and you tilt it, and it pushes against the side of the pan, it starts to ripple. So you watch these lava flows, and they just come off, and then if they hit something, they hit it and they buckle, and the lava behind you is not going anywhere, so it just starts to push, and it buckles until it says, I can't go any further, and then it breaks out on the other side, and it continues. So it's constantly moving. It really is like a live entity. Lava is generally degassed pohoi, and it loses its temperature, but most of the flows that you see are generated from, a lot of you see is generated from intense fountain activity. So the fire fountains that are kind of a rarity here in Hawaii occurs when suddenly it breaks open and then the gas starts to come out. it at extraordinary rate and pressure. And so it's a gas explosion, and it's just expanding gases, which propels everything upward.
So these chunks fly through the air.
So the chunks fly through the air. It's totally, it's degassed because all the gas is coming out. It's a gas-propelled eruption. And then the chunks fall down, and then they're remobilized. And so they start to stick. They've lost their gas. They've already cooled down a bit, and now they're stuck on the slope of the volcano. But it continues to erupt. Stuff is overflowing, and then it just moves. And now this is at a more glacial pace. And so it moves, and then that's when it kind of congeals. Usually it finds a little place to mobilize in a valley, and it's a very slow moving, generally very slow moving.
But the composition of the two kinds is basically the same aside from the gas.
It's the same composition. Both are, silver rich, 50% oxide. They have the same. Now you may help me on this one, Kelly, because I kind of forgot. On the Kelly's a geologist too, so.
Great, now my secret's out.
Yeah, I know, but on Mauna Kea, you're going to see a totally different type of lava. It's not hohoi, and it's not it's actually called Hawaii, and it's more of an andesitic. It's more
silicon in the content of the eruption.
Yeah.
So when the lava comes up from these deep pockets, it taps into big pools of liquid magma that might have different compositions. In the main, right, it's all the same. But as you can imagine, as the lava cools, some of it, when it crystallizes out, there's kind of a dregs that's still molten, and when those dregs erupt, they can have a different composition than the whole amount. Okay, and so you can get andesitic, means that there's a little bit more silicon in it. It tends to be erupt at a higher temperature, and it tends not to be very flowy. It tends to be very fire fountains, plumes, cinder cones kind of thing, and right,
yeah, we go. Okay, so anyway, thank you. And the only thing you should look for when you go up to the cones, finally go here, is look for some of the cones actually right. That's from the fire fountain glacier, and you can see them sculpted. So just cut, so the ones that look pristine, it's like okay, they're fine. But look for the sculpted cones, because that's where, yeah. So that's kind of a really unique feature.
So as they say in Russian,
okay,
which means let's go.
Okay, thank you very much.